Hello, distinguished guests, partners, supporters, and friends. Welcome to the Computer History Museum 2021 Fellow Awards. It's wonderful to have you with us for this exclusive backstage portion of our program. I'm Dr. Talithia Williams, a mathematics professor at Harvey Mudd College, and I'm super excited to be your co-host for tonight's celebration. Now, since 1987, the CHM Fellow Awards have honored distinguished technology pioneers, unsung heroes and legends for their significant contributions to the advancement of computing and the evolution of the digital age. Now, I want to give a special shout out to all of our fellows from previous years who've joined us tonight. If you're a CHM Fellow, be sure to tell us in the chat. And the chat is not just for fellows. We invite all of you to add your voice via chat or through social media with the hashtag CHM Fellows. We want you to be a part of this conversation. Well, now it's time to get started. So please join me in welcoming CHM President and CEO, Dan Lewin.
Great. Well, thank you, Talithia. It's great to have you as a friend of CHM and co-host tonight. I'm excited to see so many friends of the museum backstage at our second 2021 virtual CHM Fellows Awards. Welcome. Thanks also to our outstanding trustees, our dedicated staff and volunteers, and our valued partners and supporters who advance our mission every day. We appreciate your passion, expertise, and energy. And thank you all for being here tonight. It's exciting to gather in honor of artificial intelligence and robotics pioneer Raj Reddy. And with us to join Raj in conversation is the former president of Stanford University, who's currently a professor of computer science, the director of the Knight Hennessy Fellows Program, and the chair of the tech firm Alphabet, John Hennessy. Raj, John, it's great to see you. In fact, it's really only fitting and appropriate that Raj should make his entrance on a robot. And I want to thank you both for joining us for this special backstage conversation. We're looking forward to hearing firsthand the stories and learnings from Raj's amazing journey. And maybe even more important, to hear Raj's thoughts about what's ahead and how AI can help solve some of today's most pressing global problems. Over to you, John. Raj.
Thank you, Daniel, and congratulations, Raj. I've had the great good fortune of knowing Raj for many years. He is the very first PhD from computer science at Stanford, so this is a great privilege for me to have this chance to talk to you. Raj, why don't you start by telling us a little bit about your first encounters with computers? What were they like? How did you get excited about using them? What kind of experience was it?
Yeah, the first time I got introduced to computers was in 1959. I was a graduate student at University of New South Wales in Australia. So my advisor said, I'm going to the computer center, why don't you come and join me? And I said, sure. And there I saw this huge vacuum tube computer taking up a big room. And the only input it had was punch cards. You typed in, and every program was a brick. This is a bunch of punch cards. You stack them together. And you did computation in stages, did a little bit of computation, then print out, punch the cards out. It only had about 1 kilobyte of memory. That too, it was not a drum or any of those things. It's a Mercury delay line memory at that time. And it was, but it did have a CRT display. And it would actually, somebody figured out how to use play music on it. And so you could actually hear the music of whatever it is thinking. So it was quite exciting, but it was kind of awesome at that time. And by the way, it was the computer, it was called Deuce by English Electric. It was designed, it is a follow-on to ACE. And if you remember the history, Alan Turing designed an architecture called ACE, a computing engine, and at Manchester, they built variations of it, but this was the first one that was commercially available that lots of people could buy. And it had one and it had a high-level programming language. It had only one data structure. It was just a matrix. Everything was a matrix. It was great to do that at the time.
Yeah, I think people don't realize how primitive these systems were. Not only small amounts of memory, but if you were to compile a program or something, first put the compiler, stack of code for the compiler on the card deck, and then the program you wanted to compile. It was, and turnaround time was long.
Right.
So how did you go from that early interest in computing to your interest in artificial intelligence? Because that's a really big jump, especially at the time you began the field.
After I graduated, I was lucky to be hired by IBM in Australia. And I was there with IBM for 3 years. And during that period, I would read, articles that I would come across, and also there would be visitors, from IBM research in Yorktown and so on. So I read about all the early work, or not all the early work, many papers by Newell and Simon and McCarthy and Minsky, Stepsford, all of those things. And that kind of said, this looks like an interesting thing I would like to do. And I applied to only CMU, Stanford and CMU, and I ended up at Stanford. And so it was, you will remember it, you may remember it. I don't know if Polya Hall is still there. We were in Polya Hall, and George Forsyth was the department head. And it was a small department, and about half a dozen faculty members at the time.
Yeah, it was a tiny department. I mean, the field was so new. There were no undergraduate majors.
Right.
There was nothing. So people were coming into it. What was your undergraduate major in?
In my undergraduate major was in engineering, civil engineering.
Civil engineering.
And my advisor took me there because they were doing structural analysis in computers, big, numerical analysis. And so when I started with IBM, I wasn't doing any of that. I was mainly a systems programmer type, and what they called me applied science representative or something. But that's all I was doing. So when I was thinking about graduate programs, I just decided, rather than do a PhD in civil engineering, I will do it in computer science. But there was no computer science program at Stanford when I arrived there in '63. And so I ended up getting admitted to the operations research program because they had a PhD program. And then McCarthy said, this was in 1964, look, they approved the formation of the department, so now we'll have a department. That was in January 1965. And so I just stayed on. That was, it was very interesting.
Well, you came to the department at an incredible time because Knuth, McCarthy, Feigenbaum, I mean, it was just Forsyth. It was really Gene Golub. It was an explosive time in the field.
Knuth came a little later, but
he came in '66, I think.
Knuth was, Forsyth was trying to recruit him right from the time I was early on, but he couldn't. He had other commitments, so he only came in '68 or '69. But that was early, early history from there.
It was. Well, when you came to Stanford as a PhD student, you had the opportunity to work on a DEC PDP-1. I know the university had just bought a different kind of computer, but we thought it might be interesting for you and us to look at a video that reminds us what those computers were like. So let's roll the video.
In 1959, computers were large, expensive, and rare. That same year, Digital Equipment Corporation, a young company based just outside of Boston, unveiled its first computer, the PDP-1. The PDP-1 was an early, iconic mini-computer, a radical design change to smaller, less expensive computers. Only 53 were made. A few went to universities like MIT and Stanford. Now, it won't surprise anyone that one of the first things that transpired on the MIT PDP-1 was the world's first video game, Space War. The PDP-1 was remarkable. It had a paper tape reader and punch to store and read data onto paper tape, a typewriter to type in and print out data, a cathode ray tube Type 30 display that allowed programmers to view and edit programs and games. And finally, it had a light pen connected to the monitor to point at objects or draw directly on the screen. The PDP-1 was a game changer. It captivated an early generation of engineers with revolutionary real-time capabilities, interactivity, live graphic display, and even sound. It launched hacker culture. Rolling Stone declared, "Ready or not, computers are coming to the people." In 1963, when Raj Reddy arrived at Stanford to start his PhD, so did a brand new PDP-1 to the AI lab led by AI pioneer John McCarthy. McCarthy, Raj's thesis advisor, suggested that perhaps he could do a class project using the new PDP-1's analog to digital converter, which allowed for analog signals like speech or music to be input into the computer. Raj got to work. He'd arrive in the evening after everyone else had left, and he'd work through the night 7 days a week just so he could have the PDP-1 all to himself. As captured in his oral history for the museum, he said,
And I thought I died and went to heaven.
what Raj began as a class project on the PDP-1 blossomed into his PhD dissertation and the first continuous speech recognition program,
Pick up every small block.
as well as the start to his life's work. Today, there are only 3 PDP-1s left in the world, 1 restored to full operation, and all are at the Computer History Museum. This PDP-1 is one of over 100,000 artifacts in the museum's collection.
Well, that's amazing, Raj. You look at those machines, and I thought the story of you, which I had the same experience. Late at night, you could get your hands on the whole machine. Students today own their machines, right? But in those days, that's how you got the work done.
Exactly. I was there for 12 hours a day, like 8 to 8 or something. The only other person that would come by is, you would remember him, professor of music called John Chowning.
Oh, yeah.
He wanted some cycles.
Yeah.
So we worked out some arrangement. So anyway, to me, in retrospect, looking at it now, that was the beginning of computers. Before that, computers would only be used for number crunching, numbers, computation. All of a sudden, there was the beginning of computers that can see and hear and do things, act. That is the beginning of the kind of, that is the forerunner to me of the smartphone, which had cameras and microphones and vibration, all kinds of things that were not conceivable. And it was all on a small form factor. And that took, 30, 40 years.
Well, in fact, late at night, it was a personal computer, albeit a pretty expensive one, but personal computer for you.
Exactly. But they did build a time-sharing system for it, so more people could use it. But it was, Steve Russell built the time-sharing system. That's the same guy that did the space war.
Right.
He was the person that did it.
Well, McCarthy was a big advocate of time sharing. And by the time I got to Stanford, we had just started putting in a lot of time sharing resources for students at large. So tell me about your first attempts at AI. I mean, this was a young field and the problems seemed almost insurmountable. They must have, given the computer power of the time. How did you really think about that? How did you get over the hurdle and really begin to make progress?
We didn't understand how much computing power will be needed to get high caliber recognition. Somehow we were all optimistic and we thought it'll all be done in 10 years or 5 years or something. But slowly, as you began to try to make computers understand or recognize speech, and that happened in the early 70s under a DARPA program called Speech Understanding Systems. Licklider was, in fact, also back at DARPA at that time. And the Speech Understanding program is the only program that had a specific 5-year goal at that time. You have to do 1,000-word vocabulary connected to speech in this, real time or something like that. And it was not at all clear it could be done, but we did it. And in fact, there are some videos on YouTube that show Harpy, and here's a systems that do that. And that was when we understood that we are very far from being able to recognize what we call USSOP, unrehearsed spontaneous speech from open population. And that is still not completely there.
Yeah.
For example, if you turn on YouTube closed captioning, you will see the large number of still words that it misses. And the new GPT-3 might fix some of them, but we don't know.
Yeah, still have a ways to go. So I want to, those early times are fascinating, but I want to talk a little bit about your role as a mentor, a leader. You have a reputation for being an incredible leader, not only of large projects, but also a personal hands-on mentor. So my first question is, did you have a personal mentor? Did you have somebody who helped inspire you as you went through your career?
Yeah, I think I was just imitating Newell, Simon, and Perlis. They're like that. They were very empowering and easy to access, easy to work with, and easy to get things done. I almost never heard no from any of them. I would go and suggest some crazy thing, and they would say, well, let me see, maybe we can make it happen. That's the kind of thing that's very important in research environments, and that is those are, if I had to say, there were mentors that are kind of helped to kind of form that thing, it would be Alan Perlis. Alan Perlis was the first Turing Award winner and the first head of the department at CMU. And of course, Newell and Simon were the founders of the field of AI and cognitive psychology. So they were all, kind of major figures in their own right, but somehow they figured out how to subsume their egos and work together to build a high caliber place. And they were also very, funny, interesting people. I remember Perlis, I went to Perlis and said, Alan, why don't you have a department? I've never had a faculty meeting. When are you going to have He says, I never have faculty meetings. It's a waste of time.
Many of his colleagues agreed with him, no doubt.
And the same thing with Simon. I would say, Herb, what do you think of X? He says, I never read newspapers or magazines or anything because they're a complete waste of time. And he followed it, except I said, but it can't be that. People watch TV not because they want to waste time, they want entertainment. But he had his own separate entertainment. They're very interesting personalities, but nevertheless, it kind of, you learn by observing how empowering they are. We had this thing called reasonable person principle. You kind of let people do anything they want. If they screw up once or twice, it's okay. You kind of say, it's a reasonable person who have done it, therefore. And after that, you might kind of tell them not to do it again. But
yeah, it's a great principle because it assumes people are coming from a valid point and not that they're out to do something negative. And it helps settle a lot of battles. So Raj, you've led a lot of great projects. What advice would you give to a young person that'd like to do work like you've done in robotics or in speech recognition? How should they think about being a leader?
Yeah, the biggest problem I think we all have is how to pick a new project, right? And usually we shy away from things that seem impossible. And so I think my recommendation would be think out of the box. Doesn't matter, even if you fail, you will achieve a lot of things that would be successful. So you must, kind of think out of the box to make things happen, and also be sufficiently humble to realize even an undergraduate might have a pretty good idea that, you shouldn't completely reject things just because an undergraduate said it so. And those are the kinds of things I think that worked out at CMU.
Well, now we're going to hear from a couple people that you've served as a mentor for in their work on Dragon systems. So let's roll the video from the Bakers.
Thank you, John. Thank you so much for allowing us to be part of this great honor to Raj. He has been so important, not only to us personally, but to so many others, and he richly deserves this honor. We first met Raj as graduate students from Rockefeller University. We had been asked to come out and give a couple of talks on our thesis work, actually instituted by Alan Newell. And by the end of the day, after we gave our talks and chatted with various people, Raj invited us to transfer out so we would have access to more computer facilities and be able to have as collaborators other people working on speech at Carnegie Mellon. So we did, and we're very glad we did. It was a wonderful experience, but it wasn't just a wonderful experience for us. Raj is really the epitome of empowerment for so many people. And although we were very certain about the areas that we wanted to pursue, there were other graduate students who weren't, and he helped steer them to be as successful as possible. And with his students and his other collaborators, he was a tremendous, and has been a tremendous catalyst for change and force for good, as can be seen by the dispersal of his many contacts and all the things they have done worldwide. He's a very shrewd judge of character, and in his very unassuming, collaborative fashion, manages to make great things happen in many domains. I'll let Jim talk a little bit about what our experience was. Jim.
So I will talk specifically about empowerment as my personal relationship with Raj while I was a graduate student. I was working on a mathematical model that's called a hidden Markov process model, and I thought it could be used for speech recognition, which was a major project that Raj was supervising, a speech recognition project at Carnegie Mellon at the time. And has continued supporting that through his career. But my approach was controversial within AI. I had not been working in AI, and I was approaching it as a math major, and it was basically a mathematical model. And AI in the early 1970s was still trying to show that it could be used for things, that computers could be used for things other than just doing a lot of computation. Computers not just can do arithmetic a million times faster than people, but it could do things that people regard as signs of intelligence. And it was somewhat controversial. If I just used a mathematical model, was that really AI or not? But Raj was very open-minded, and he warned me that, what I was trying to work on might not work. It had never been done before. And I think maybe he suspected that maybe it would fail, but he would empower me and let me try it. And I tried it, and it worked. No one had done it before, but it turned out IBM Research Group was also doing it at the same time, but we didn't know about each other. And together, probably more due to publicity that IBM got, but in any case, hidden Markov modeling, which was the technique that I was using at Carnegie Mellon, did succeed, and it grew to become actually the leading technique in speech recognition for several decades. But this is just a symbol of one thing that Raj did for one student. He did empowerment for all of his students, but much more than that, he took a long-term vision in AI and had looked at grand challenges and at the long-term future of AI as a contribution to humanity. So he affected not only hundreds of people that he worked with directly, but thousands, tens of thousands of people that he inspired, and millions of people that were affected by projects and initiatives that he initiated and inspired.
Congratulations, Raj. It's a great day.
Well, thank you, Janet and James. That was great. Raj, anything you want to add? Corrections? Any perspective on this?
Yeah, Jim was mild, and I said, Jim, I know hidden Markov models. At Stanford, I was the only one that got an A+ in statistics, but it's not going to work here. But if you want to do it, why not? Let's see. You may waste 6 months of your time, but I think the great thing about it is, even after 40 years, that is the model all the speech recognition systems are using. The deep learning comes in, but it's not complete architecture. Deep learning is used mainly to learn certain things, but hidden Markov model is still embedded there in almost all the systems.
Yeah. So we want to shift gears now and talk about your role in using technology in service to society and the work you've done. For example, in the 2000s, you pioneered a project called the Million Book Project to try to get books and digital content out there, creating inclusion and making content available to people. Tell us about some of that work that you did on that project, or I know you've also done work with Rajiv Gandhi University in India. I'm eager to hear about your work in this role.
So the Million Book Project was in fact a very exciting, interesting experiment that has the beginnings going again back to John McCarthy. When we saw we were all producing theses, students were producing theses on the computer, and he said, why don't you put it on the computer and then let people access it? And then 10 years later, when I was at Centre Mondial, I invited John to kind of come and help us to create a digital library project. And at that time, the scanners were still not that good. So we even decided it's okay to simply manually type in the books that we want to have online. And it turns out, if you look at the millions of books, we estimated like maybe there are 100 million books. The number of books that are that are still routinely read are a handful, whether Shakespeare or Jane Austen or Walter Scott or something. And so we said maybe there are 10,000 good books that everybody would want to have. And later on, the Gutenberg project, people did exactly that, except it was all simple text. That was not very satisfactory. So about by mid-90s, we began to have scanners that could be used for high-speed scanning of books and so on. In 1995, I remember we had a meeting, a digital library meeting. Before that, we used to call it electronic books, right? And Vint Cerf and Bob Kahn were there. And Vint came up with an idea, digital library. That's the first time I heard the name digital library in 1995. And now it's kind of routinely used by everybody. So I think it's, we scanned all the books. We stopped, wisely when Google started scanning books because they had much bigger resources and a lot more things to do. But even they ran into this damn copyright problem, which unfortunately is only relevant for a very small number, maybe 1% of the people. But everybody comes under the thing. And so a lot of orphan books and things that would be interesting if they were online, but they were under copyright, so nobody wants to scan it because of the liability issues and all kinds of things. So that problem is still there. And I think, it's something we ought to figure out how to resolve.
Well, copyright law, unfortunately, was written many years ago when a book was a hard copy thing that was printed and very expensive, and we never dealt with the changes that technology wrought it
is mainly the fact that lots of things that are published that are lost forever, and magazines and newspapers, especially newspapers. I would love to be able to go read, newspapers of the day on many important events of the world. Maybe you get to see the archives of New York Times, but if you don't read English and you want to see it in Chinese or Hindi or something, They're not there. And it would be good if we can capture them.
You know, and one of the great ironies, of course, the searching digital libraries was the original inspiration for Larry Page to begin the work that eventually led to the Google search engine. So it's these grand challenges, like building a really high quality digital library, the challenge of building a vehicle that could drive autonomously through the desert. These great challenges really do push the field forward.
Yes, very much so. There are still a lot of things we'd like to do, but we don't know yet how to do. And but they certainly help to the thing. The one thing we did do was Alan Kay was responsible for getting me involved in it, is to set up the Centre Mondial in Paris, which in 1980 tried to provide the access to technology for people who would otherwise not able to see or hear or do things. And it was possible even then to think about how healthcare or education could be enhanced through the use of information technology. Nicholas Negroponte and Terry Winograd and Alan Kay were right at the forefront of it.
Well, speak of Alan, we're now gonna hear from Alan. He's a CHM Fellow, of course, a faculty member still at UCLA and works on the Viewpoints Research Institute. We're delighted to have you here tonight, Alan, to give us some insight on Raj's work.
Thanks, John. It's a great pleasure to be part of the celebration for inducting Raj Reddy, my old friend from more than 50 years ago, into the Computer History Museum Hall of Fellows. I think about Raj, there are three really unusual things that need to be mentioned. First, he's a world-class research scientist, and this is recognized by his Turing Award, which is sometimes called the Nobel Prize of Computing. But even rarer are people who can run world-class research groups, and he's done this a number of times over many years. And even rarer still is this idea of research manager. I think this is the hardest thing to do well in computer research, and it is certainly unusual for somebody who is such a good research scientist to also be able to handle this much larger, much more complicated job. And Raj has been stellar at all of these over the years. And I should mention that in the early 80s, I was approached by Jean-Jacques Servan-Schreiber, who was trying to start a large worldwide research community operating out of France to help the third world deal with the transitions of the 20th century. And Jean-Jacques contacted me, and I gave him a list of prominent computer people who I thought would be very interested in helping in this project. On that list was Raj Reddy, and he in fact was one of the major contributors to this project, which is called the Centre Mondial, the World Center for Human Resources. So all in all, I think inducting Raj into the Hall of Fellows is long overdue. And it's great to have him be a part of it because in many ways, the Computer History Museum Hall of Fellows is the most representative of far-reaching ideas of all of the honors you can get in computing. It's wider, broader, and deeper than, for instance, the Turing Award. It has many more kinds of people inducted into it. And it's so wonderful that Raj will be part of this starting now, I guess. Thank you very much, and congrats, Raj. I hope to see you again soon sometime. Bye-bye.
Thank you, Alan. Well, any thoughts on Alan's message there, Raj?
No, Alan has always been a role model for many of us of thinking out of the box. He was the guy in 68 or 69, came up with the idea of Dynabook. 20, 30 years later, now every one of us uses the laptops of the kind he talked about. And it's also, he has done a number of things in programming languages like Smalltalk and all of the things. But the thing that to me is impressive is his broad range of interests. He's an accomplished musician, among other things. And so it was good that we were part of a team together to try to do something good in 80s. And,
well, the two of you are two people I always think of who think about the future, who inspire us to go forward, and who try things that many people wouldn't try because they think they're too hard.
That is true.
So I'm interested, Raj, in what are you really excited about seeing happen in the AI field now? I mean, we're standing on the cusp of what, with deep learning, really a remarkable revolution. What do you see as the big opportunities going forward?
Right. So I think the opportunities that are waiting to be harvested are cars that drive themselves. I know there are still problems with them. I know there are software issues and so on. However, even now, the caliber is such that they would eliminate 80% of the accidents that human beings would get into. So having a man-machine symbiosis or human-machine symbiosis, where computers kind of take over when a human being is trying to do something stupid, and the human being can override the computer if he thinks that he wants to do it in a certain way. And there are some ethical questions saying, supposing I'm drunk, I'm trying to override the computer, what would you do, kind of thing. Looking at other unsolved problems, that we've talked about this problem of, can a computer read a textbook and answer the questions at the end of the chapter? And it's turning out, even now, it's still a very hard problem. And more recent advances in language modeling of transformers and GPT-2, GPT-3 is making a huge impact on it. And so much so, Allen Institute for AI, under Oren Etzioni and Peter Clark and so on, they have been working on this problem. About 5 years ago, when they took, I said, forget about taking AP biology, just take 8th grade science exam or anything, and to see if you can actually answer those questions. And it turned out the system they had in 2015 or 14 got a F grade. It failed, got 50% or something. And it took them 4 years of looking at, most of the issues were not of deep intellectual things. It's simply their ability to understand common sense terms in language and interpreting them. So for example, if you said, go to the bank, you don't know whether you were talking about a bank with money or a bank of the river or something. And with the context, you can say what kind of a bank you're talking about. So that's what is being involved. So recently, about 2 years ago, I think, they showed that they're able to get an A grade on the 8th grade test using the language modeling advances that happened in the last 5 years. Now it looks even better with GPT-3. So we have to wait and see. So the people at OpenAI are doing a great job. And so we need to figure out a way of encouraging people like that and other activities like that. So I think that's where we need to go.
So Raj, what do you think about this problem of integrating AI systems with people? Because I know one of the problems that has existed for the cars is people break traffic laws all the time. And the cars don't expect people, autonomous vehicles don't expect people to break traffic laws because they don't break them. How do we think about that integration?
This is the thing I think that is waiting to be solved, the man-machine symbiosis. That is, if two people are collaborating together, forget about a man and a machine. If you and I, it's like, those races where they tie your legs together and you have to run. You can't, it's a complicated issue. Each person wants to do something different. The same is true with computer and so on. So all you can do is you can say, human being can override. If you do that, and sometimes if the human being is drunk, he should not be overriding. So the question is, how do you design systems so that they are much more omniscient and understand what the situation is, so that they can actually help with the thing, So man-machine systems, that is the hardest thing, that we have. It's obvious to human beings when we see something, but building systems that will also understand and do things, the common sense things. There are a set of things, I think they're called Winograd schema, after Terry Winograd, where they have made up hundreds of sentences, where by just changing one word, the whole sentence meaning is changed completely. And how do you, in order to understand why the meaning is changed, you need to understand the world and common sense about what happens in the world. And so there are, things that still we are far away. I'm not sure when we'll have any kind of AI at all, maybe 1,000 years or something. But right now, I don't think we should worry about computers taking over the world or robots taking over the world.
No. Well, Raj, this has been a really great discussion. Congratulations. This is really a well-earned honor. And we wish you best wishes. And I can't wait to see you in person soon.
Thank you, John. It's great to see you again. And we'll see you again a little later.
Okay. I'll turn it back to Daniel.
Right.
Thank you, John, and thank you, Raj. That was fascinating discussion. You covered so much ground. As we close this backstage portion of the program, I'd like to express appreciation to our education sponsors, Tech First, the KLA Foundation, and Oracle. And a special thank you to our headline sponsor, Accenture, for helping make possible the 2021 Fellow Awards series, not only tonight, but throughout this year. For 8 years, Accenture has supported this important program and helped capture and share the stories of our remarkable fellows. I hope the conversation we heard tonight inspires you to think about how tech can serve humanity. So as you may have already seen on our virtual platform, we are inviting you to share your voice by recording a video. As an example, we asked Emma McGugan, Global Lead of Intelligent Platform Services at Accenture, to share her thoughts. Let's hear what she has to say.
It's pioneers like Raj who have really created this opportunity, building followership, building teams, opening doors, challenging our thinking. And it's with great excitement that I learn of his recognition, and it's with even more excitement that I think we all as leaders have this unique opportunity and this unique, maybe dare I say it, obligation to empower others.
Thanks, Emma. After tonight's show, we invite all of you to join Emma by recording a video on our event platform. And now it's time to move to the main stage, where we will be joined by many others from around the world for the 2021 Fellow Awards ceremony in honor of Raj Reddy.
Good evening. I'm Dr. Talithia Williams. Now, by day, I'm a mathematics professor at Harvey Mudd College, but tonight I am excited to be co-host for the Computer History Museum's 2021 Fellow Awards. For over 3 decades, CHM Fellow Awards have recognized technology pioneers, legends, and unsung heroes who've advanced the field of computing and propelled humanity forward. The first fellow was Grace Murray Hopper, a trailblazer of software programming. And since Grace, CHM has presented this prestigious award to 89 fellows, including many who are in the audience tonight. Truly, these distinguished fellows have changed our world. 2021 marks a new era for the museum's Fellow Awards. This is our second virtual award ceremony, part of a year-long celebration with events and companion content. Through the power of technology, we are connecting people around the world as part of CHM's growing community. We want to give a special welcome to audiences in India and China who are enjoying the program in English, Hindi, and Mandarin. More people from more countries are joining us for this Fellows Award program than ever before. Here are the ways that you can participate. Add your comments to the live chat during the event, or join the conversation on social media using the hashtag CHMFellows. We also want you to record a video message on our virtual event platform. And later in the program, you'll even have the chance to place a bet on the future. We invite each of you to add your voice. Now, I'm thrilled to introduce CHM President and CEO Daniel Lewin. Daniel has dedicated his career to advancing innovative technologies with positive impact. Before coming to lead the museum in 2018, he was an original member of the Apple Macintosh team, co-founder with Steve Jobs of Next, and a Microsoft executive leading global venture capital outreach and an array of tech for good initiatives. He's also served as chair of the Silicon Valley Community Foundation, the largest community foundation in the world. Drawing on his extensive expertise in Silicon Valley, Daniel is spearheading the transformation of CHM into a leading museum at the intersection of technology and humanity for the 21st century. Please welcome Daniel Lewin.
Well, thank you, Talithia. It's wonderful to have you as a friend of CHM and as co-host for this special Fellow Award ceremony. Good evening, everyone, and welcome. At CHM, our mission is to decode technology, to decipher, demystify, and interpret technology, what it is, where it came from, why it matters, and most importantly, how we can use it to shape a better future. Tonight, we're going to learn about a true pioneer in AI and robotics. So it only seems appropriate to bring Squee, the robot squirrel, to join me on stage. Squee is a simple analog robot from 70 years ago, the earliest days of robotics. He could receive sensory input and take appropriate action. In Squee's case, this meant hunting for nuts, actually illuminated tennis balls, and bringing them back to his nest. Squee is just one of the more than 100,000 artifacts and more than 1,000 oral histories in CHM's permanent collection, the leading collection for understanding the history and impact of technology and the innovators of our digital age. As important as it is for us to preserve the history for generations to come, our goal is to do more, much more. Our ability to solve the pressing problems of our time, to connect with others and express our humanity is increasingly defined by the technologies we create and use. For this reason, we're devoted to helping shape a better future by decoding our computing past, our digital present, and the future impact on humanity. Well, how do we do this? Well, we gather here tonight, and that's one way. Pioneers and visionaries like our 2021 fellow Raj Reddy can inspire us to build a better future. Thanks to the work of Raj and his students, artificial intelligence, robotics, and other technologies are redefining what it means to be human. They are reshaping how we learn, work, live, and play. So at CHM, we're working to earn your trust by illuminating the incredible promise and the perils of technology. We're exploring new ways to create meaningful experiences and insights. And we're transforming our systems and digital capabilities to engage new audiences and demonstrate impact around the world. We're showcasing diverse voices and bringing people together with fresh programming and content to empower our growing community. We believe that together we can chart a positive path forward that will benefit all of us. And that's why I'm particularly excited about this year's Virtual Fellow Awards program, that we're using technology to build community and engage people around the world. Who are the pioneers and visionaries we celebrate as CHM Fellows? How can they inspire us to build a better future? Here's a short video to share more about our Fellows Award program and to let you hear from some of our past honorees.
In the words of Dr. Katherine Johnson, and I quote, "You are providing a platform for so many to share their story, and together we are rewriting history in a way that allows everyone to see their place."
For more than 3 decades, the Computer History Museum has reserved one honor for a distinguished circle of individuals who have advanced the field of computing.
So I figured that if I could start on the ground floor with other people, then I'd have a chance to get ahead.
And that was what led me to write the first compiler back in 1952.
And it was set up as a crusade rather than to make money.
The CHM Fellow Awards recognize technology pioneers, legends, and unsung heroes who have illuminated our world and propelled humanity forward.
The semiconductor industry has made bigger changes in a few decades than printing has over a few centuries.
When these things actually start to connect, you get the wow effect.
Democracy, freedom, prosperity, they all stem from technological innovation.
We've got to make a society that will last, that is sustainable as a society.
That's one of the reasons I developed my computer and gave it away. I wanted to help that revolution go forward.
If every one of us does our job well, it'll all go very interesting.
When the ideas start, they are fragile and they're new. And most people don't understand them. And the things that are fragile need to be protected.
They are the dreamers who imagine beyond what is, the disruptors who challenge convention, the builders who transform our world. They are the history makers who inspire us all to keep exploring and creating new ways to shape a better future for everyone.
Building on this 30-year tradition, CHM is pleased to honor our 2021 fellows. Collaborative technology creator and entrepreneur Raymond Ozzie. Tonight's honoree, AI and robotics pioneer Raj Reddy. Computer artist Lillian Schwartz. And computer graphics and hypertext pioneer Andreas van Dam. So please join me in giving a big round of applause for these distinguished honorees. We really do have a great 2021 class, and I'm excited to continue this year of celebrations. The museum is honored to shine a light on each fellow's innovative spirit, to preserve and share their remarkable stories, to examine the relevance of their work for us today, and to inspire the next generation. Through programs like this, we're exploring the life's work and impact of each of our honorees. The museum also offers a rich array of companion collections, including new extensive oral histories of each 2021 fellow. Our team has also created compelling articles and films, and all of this content is available on our website and our online platforms to anyone, anywhere. All that we have in store for you for the 2021 Fellow Awards program would not be possible without the generous support of our sponsors. So many individuals, foundations, companies have helped us to surmount the unprecedented challenges during this pandemic year. And now we're emerging stronger and more focused on our mission to serve you. For our fellow awards, thank you to our education sponsors, First Tech, the KLA Foundation, and Oracle. And we want to express our special appreciation to the program's headline sponsor, Accenture. Accenture embraces the power of change through ideas and a culture of innovation that makes an impact across the globe. This is the 8th year that Accenture has provided extraordinary support as the program's headline sponsor. On behalf of CHM, our Board of Trustees, staff, and volunteers, I say thank you. It's now my pleasure to introduce CHM Trustee and Group Chief Executive of Technology and Chief Technology Officer of Accenture, Paul Doherty.
Thanks so much, Daniel. It's such a pleasure to be part of the Computer History Museum and the 2021 Fellows event honoring Raj Reddy and his contributions to the advancement of technology as a force for positive social impact. At Accenture, we see the power and the promise that technology combined with human ingenuity has to change people's lives, but it also has the power to help individuals adapt to change. I think we all recognize that the pandemic has acted as a change agent, an accelerant for technology. What's getting less attention is the human experience. Over the past year, billions of people changed their behavior instantaneously in profound ways. There's really no historical precedent, and I don't think we can yet fully appreciate the impact. Focusing on this human experience will shape the organizations that will succeed and thrive in the future. And we think about this moment in two ways. First, it's a moment of truth. We're creating the technology foundations for the future. So factoring in innovation, accessibility, sustainability, and collaborative and open environments is critical. And second, it's a moment of trust. We have to assume we're meeting our employees, our customers, our students and communities where they are and equipping them with the ability to learn, to address the challenges of this new environment, and also assuring we maintain human connections. We're living in such an exciting time, fueled by circumstance, innovation, and the human spirit, where more and more individuals can achieve their full potential due to the groundbreaking work and lifetime commitment of amazing innovators and leaders like Raj, who recognized early on that while talent is everywhere, too often opportunity is not. At Accenture, we share these values and this commitment to human ingenuity and potential, and that's why I'm so pleased and proud to be on the Board of Trustees of the Computer History Museum and to represent Accenture as sponsor of the 2021 Fellows. Thank you, and back to you, Daniel.
Thank you, Paul, and everyone at Accenture for your continued support of this milestone program and the ways you're making a difference for us at CHM as a valued strategic partner. Now, to turn to the distinguished 2021 fellow we're honoring tonight. Do you control your phone with voice commands? Have you thought about the fact that your car was assembled by robots? Have you read books online for free? Indian-American computer scientist and professor Raj Reddy and his students have pioneered artificial intelligence, speech recognition, robotics, universal access to information. Raj has devoted much of his life's work to how technology can serve society, particularly in education and in bridging the digital divide through access to information. Tonight, we honor Raj Reddy, one of the computing world's most accomplished pioneers. Raj has played many roles over his 5-decade career. He's an innovator, a visionary, a professor, a mentor, a collaborator, a leader, and a friend to so many people. So now let's learn about Raj's journey.
My complete name is Dabala Rajagopal Reddy. I shortened it to Raj Reddy. I've gone by that name for now almost 60, 70 years. I come from a small village called Khatur. I was the first and maybe the only one to get a degree. And my elder brothers could have gone to college. But my father said, look, somebody has to look after all this property and land.
After graduating from Guindy Engineering College in India,
Raj went off to the University of New South Wales in Australia to pursue his master's degree in civil engineering. Here, he was first introduced to computers. After graduating, he started a career at IBM, where he made a discovery.
Then I was reading papers on artificial intelligence. And I said, my gosh, I wonder if it is really possible. If it is, I should be right there.
In 1963, Raj pursued a PhD at Stanford, pioneering connected speech recognition. He worked under AI pioneer John McCarthy, who had just been awarded a DARPA grant and a dedicated computer to research AI.
It was a PDP-1. They were just coming out at that time, 1963. There are a number of people, like Steve Russell, who did the space war. All of them would work 9 to 5, and after that the computer would be completely empty. Nobody else would be using it. So I would work every night, 7 days a week, all night, And one of the suggestions was, hey, we just got this computer, it has an everyday converter and you can digitize speech. Maybe one of the students can build a speech recognition system. So I said, I'll do it, and that's how I got into it.
Raj was uniquely equipped for the challenge.
I come from Indian language, Sanskrit and so on, right? They're all phonetically based. You speak what you write, and you write what you speak. I said, let me see if I can recognize vowels as the first thing. And I built a pretty good working vowel recognizer. I was trying to understand the connected speech recognition, and then you apply it to some application like hand-eye system controlling some computer with voice.
In 1969, Raj moved to Carnegie Mellon University, becoming the fourth pillar of a world-class computer science department.
The great thing about the people that were there at that time, they had that expansive view. Anything goes. If somebody wanted to come and do music, they could do that. In that sense, they did not limit what you could and could not do within computer science.
As a professor, Raj worked alongside his students, empowering them to make significant contributions to the field of speech recognition.
You learn as much from students as you learn from senior people sometimes. But you must be open and willing.
In 1979, Raj founded and led the Robotics Institute, the first robotics department at any U.S. university.
Autonomous systems, the autonomous vehicle projects, and the drones, all of that came out of there. And the other one is, manufacturing automation.
Raj later went on to create and encourage world-class centers and institutes at CMU. Raj believed that computing could be a broader field with wider social impact than the studies of computers themselves.
So much of the work in the last 20 years has been technology in service of society.
Raj was instrumental in building le Centre Mondial Informatique et Ressources Humaines with the French government, bringing computing technology to developing nations. He helped launch the Million Book Project to make digitized books available online worldwide, and he co-founded Rajiv Gandhi University of Knowledge Technologies in India, providing education to students from rural villages.
When they graduate with a degree, they were the first child in their family to ever go to college and graduate from school. I have been in this birth of computing from the beginning, 1959. I was fortunate to be in the right place at the right time to kind of be exposed to all these things. And I feel very lucky.
What an incredible story. I don't know if you're looking in the chat, but there are dozens of Raj's students riffing, going back and forth. This person, Raj Reddy, has inspired so many people and touched so many people around the world with his insight, innovation, and energy. It's just unbelievable. And it's really actually even more amazing when we decode what's behind his work. For example, let's just think about a few of the really hard problems that needed to be solved to enable computers to understand speech. How can Siri understand the natural flow of continuous speech? How can a computer decipher meaning among words that sound the same, such as jeans as in pants or genes as in DNA? Or Alexa, how can Alexa work for everybody, no matter their accent or speech patterns? And the list goes on. So tonight, as we salute Raj for his remarkable vision about what is possible through new technologies and his sustained effort to make those dreams a reality, especially in speech recognition, one of computing's grand challenges. We also honor Raj for his exceptional impact on people and society. When we asked Raj what one word of advice, he would offer to a young person starting out in their career, he chose empower. And as you'll see, Raj's life has exemplified this advice, empowering humanity in 3 dimensions: empowering innovators, empowering organizations to contribute to positive change, and even empowering humanity through technology to increase access and equity. So to kick things off, we've invited 2 special guests to offer a tribute to Raj. Our first is known around the world as an artificial intelligence expert, having led different AI efforts in the US or China at Apple, Google, and Microsoft. As one of Raj's PhD students at Carnegie Mellon, he developed a speaker-independent continuous speech recognition system. He's now a venture capitalist and a best-selling author, joining us from Beijing. To introduce this speaker, I'd like to welcome someone who I'm sure you all know, someone who might not be with us if it weren't for Raj and his students. Please welcome Siri.
Hi, Daniel. I'm so glad to be here. How can I help you?
Siri, who's our next speaker?
Okay, Daniel. Here's what I found. Our next speaker is Kai-Fu Lee.
Thank you, Siri. It's an honor to have this opportunity to talk about my mentor, Raj Reddy. I remember when I started at Carnegie Mellon, Raj was the one who showed me a vision where in the future, people can talk to computers and how this would change the world. And he put it in the context of all the other changes that were happening with robotics and artificial intelligence. So I was instantly attracted to spend my life on AI, which I have. But even more importantly was about a year down working with Raj, but using expert systems on speech recognition, which was the project that he put me on. I ran into a lot of problems and found that the expert systems approach would be very fragile and would not be really scalable and solve the problem of speech recognition. So as a lowly grad student, I thought for a long time whether I could drum up the courage to talk to Raj, and I did. And I always remember the session that I had with him where I said, Raj, I love working with you. I love speech recognition, but I want to use machine learning on speech recognition, not expert systems. And here's my reasoning. After listening to my reasoning, he thought for a little bit, and he said something that was really profound. He said, Kai-Fu, I don't agree with you, but I will support you. And I was a bit puzzled by that. The meeting kind of ended, but I moved on and started building machine learning-based speech recognition. And I needed more machines, I needed more data, because all these AI machine learning algorithms are data hungry and machine hungry. And Raj not only gave me the permission to work on machine learning-based speech recognition, but he got me the resources. He got DARPA to collect a lot of data. He bought 30 plus workstations that I could use. And that really made my PhD thesis possible. So it was not just permitting me to work on something that he didn't think would work, but it was giving me an opportunity with abundant resources to pursue my dream. So this is something for which I will always be grateful. But I think even more than that, years later, I talked to Raj and I said, why would you support a grad student who didn't know what he was doing? And he said to me that in the pursuit of scientific endeavor, we are all equals, that he respected me as an intellectual, and he felt I should pursue something I'm more passionate in, that's more likely to lead to an impact than something that he demands that I work on. So this kind of leadership has made a big impact in my life. It was not just that I ended up writing an impactful PhD thesis with the permission given by Raj, but that I was taught an incredibly important leadership skill. The skill is that when you lead smart people, you need to treat them like your equals. When they have an idea they want to pursue, you as their manager or leader have the responsibility to support them, to find the resources, and put everything you can to help them become successful. And I think it was this kind of a leadership that really helped my entire career, from Microsoft to Apple to Google, and now to my own VC company. So I'm deeply, deeply, deeply appreciative of Raj, not just for being my mentor, not just for teaching me speech recognition, not just for giving me the freedom to pursue what I want to pursue, but teaching me an incredibly important lesson in leadership.
Thanks, Kai-Fu. I love your story. A profound leadership lesson on empowering innovators and others around you. Our next guest is a trailblazer in AI, computer-aided industrial design in China. He served as president of Zhejiang University and is now vice president of the Chinese Academy of Engineering. He led the China effort of the Million Books Project that Raj spearheaded with collaborators in several countries, for the first time making more than 1 million books accessible online, anytime, for anyone, for free. Let's welcome from Hangzhou, Dr. Yun Hunpan.
尊敬的赖迪教授、女士们、先生们，大家好。首先，我要热烈祝贺 Raj Reddy 教授被授予计算机历史博物馆的2021 Fellow。Dr. Reddy 从事于人工智能和计算的科研工作，从他早期的人工智能专家系统到全球数字图书馆，几十年研究的很多工作都可以成为计算机历史的里程碑。因此，他被授予计算机博物馆2021年的 Fellow， 让世代的人记住这些伟大的贡献。Dr. Reddy 因此获得这一光荣的称号，当之无愧。我和 Dr. Reddy 的合作起源于 CMU 另一位杰出的科学家，他就是 Herbert 西蒙教授。1987年，西蒙教授推荐我进入 Reddy 教授领导的 CMU 的机器人研究所做访问学者。我返回浙江大学以后，先后就任计算机教授、系主任、校长，就和 Dr. Reddy 共同推动了两校师生的合作和交流。上一世纪末 ，Dr. Reddy 提出了100万册数字图书馆计划。他的目标是让任何人、任何时候、任何地方都可以访问任何知识。浙江大学和 CMU 的图书馆率先响应，中美很多大学都共同参与合作，成功的数字化了100万册图书，这也开启了一个可以给全人类带来福音的项目。之后，数字图书馆在中国得到了教育部的不断支持。通过持续的建设，现在已经有250万册图书进行数字化，数据的容量达到了1.5 PB， 年点击率达到了2.5亿次，服务的用户1000余万人次。在中国境内有800余家共建共享的用户，在海外也有40余家，包括美清、长春等大学在内的合作共享的成员。20多年来，我们一起合作在中国、美国、印度、埃及等地举办了数字图书馆的国际研讨会。Raj Reddy 教授多次在会议上发表主旨报告，指导和把握数字图书馆的发展方向。 Dr. Reddy 发起的授图书馆的计划，极大地推动了全球计算机界和图书馆的全面合作。Reddy 教授贡献了他杰出的智慧，不仅为中美百万册授图书馆，而且也为学术大数据的形成打下了重要的基础。2012年，联合国教科文组织的总干事博卡瓦女士、助理总干事卡隆基女士到浙江大学2次是专程来参观授图书馆。2013年11月，尤乃斯国的第37次大会一致通过建立国际工程科技知识中心。Dr. Reddy 和我共同担任知识中心的国际技术顾问委员会的主任。今天，当我们回顾从20世纪的专家系统和知识工程，到本世纪的授图书馆和科技知识中心的这样一种发展的历程，我们还可以看出一条人工智能是如何从 1.0 走向 2.0 的发展轨迹。在一个由信息、物理和人类社会新构成的3元空间中，这是一条将数据、知识和人的智慧结合起来的人工智能发展新路。它的目的就是用信息的服务造福全人类。这切切就是 Dr. Reddy 所倡导的，并且值得全球信息科学家共同合作奋斗的伟大目标。因此，我想再说一次， Dr. Reddy 的贡献值得永远铭刻上人类计算机发展历史的丰碑。谢谢各位。
Thank you, Dr. Pan. It's amazing to see how building access to information through technology can build equity and empower diversity around the world. And now, it's time to present the 2021 Fellow Award to Raj Reddy. Joining us live to make the presentation is a pioneer in the field of AI, often referred to as the father of expert systems. He was instrumental in moving AI out of the laboratory and into the real world, developing several successful expert systems companies. He was a founding member of the Computer Science Department and founder of the Knowledge Systems Laboratory at Stanford University. In recognition for these achievements, he received our Fellow Award in 2012. He also served for 13 years on the museum's board. Please welcome Dr. Ed Feigenbaum.
Thanks, Daniel, and thanks also to your superb staff for giving me the privilege, actually the joy, of presenting the Computer History Museum Fellows Award to Raj Reddy. He is a friend that I value most deeply in my life. Indeed, I've known Raj longer than I have known any other active AI scientist. We met on the first day that I was a professor at Stanford, early in January 1965. I went to John McCarthy's time-sharing laboratory to look around. There I met a thin Indian graduate student displaying and analyzing speech waveforms on the display of a PDP-1 computer. Same kind of computer that you have seen on your visits to the museum. That student was Raj, pioneering AI's speech understanding problem, work that amazingly today we just take for granted. Raj is the father of speech understanding, with emphasis not only on speech, but also on understanding, which is still one of AI's frontier problems. Raj's vision not only looked far, but has looked widely, especially promoting and organizing projects that are vast in scope, to bring the gifts of information technology to people without these resources in mostly Asian countries. His Million Books online project gave them books in their own languages and achieved much more than 1 million books. For me, the summit of his humanitarian achievements was his efforts in India to establish a set of new colleges and research centers the various Indian Institutes of Information Technology, and the Rajiv Gandhi University of Knowledge Technologies, allowing low-income, gifted, rural youth, women as well as men, to gain a modern and valuable education. Among Raj's several awards for humanitarian contributions, this one is my favorite. India expressed its gratitude to Raj by awarding him one of India's highest civilian awards, the Padma Bhushan for, quote, distinguished service of a high order to the nation, unquote. But back to computer history. For his scientific achievements in applications of AI, in 1994, Raj won the Acm Touring Award, which, as you know, is sometimes referred to as the Nobel Prize of Computing. Raj is a great role model for all young scientists in all countries. Tonight, the Computer History Museum honors Raj with its Fellows Award. Raj, I will take this trophy of the Fellows Award and hand it to you bit by bit.
Thank you, Ed. This is great to have you, and thank you to receive this award from you. As you probably don't remember, but you changed my life 50 years ago. I was all ready to go to Berkeley because they made me an offer to come and join their computer science. And Ed came to me and said, "You're going to Berkeley? Before you do that, you should consider CMU." And he called up Alan Newell, and then they invited me over the same day. And next day I went there, and the following day I had the offer. And it only took like 3 days to get an offer from CMU, whereas it took more like 6 months to get an offer from Berkeley. But be that as it may, Ed changed my life. And so I kept going back to him. For example, when we started AAAI, we needed a president and a president-elect. Again, I went to Ed and saying, Alan Newell has agreed to be a president and you have to become the president-elect. And he said, yes. So we have a long history going back to the 1960s, and it's wonderful. Thank you, Ed. It is my great honor to be selected as a fellow of the Computer History Museum. The Hall of Fellows is indeed the who's who of computing field. Many of them have been friends and colleagues for years. I want to thank my family, my wife of 55 years, Anu, and my 2 daughters, Shamala and Geeta, for their love and support and tolerating my 7-day-a-week work schedule. I grew up in a little village of 500 people in South India during World War II. At that time, we had no running water, no electricity, no doctor, and a 1-room primary school. My father and mother never finished school. When I started school, we had no money for paper and pencils, so we were taught how to write by writing letters in the sand. Everyone in the village walked barefoot. I started wearing shoes only when I went to Loyola College at the age of 15. They were not very comfortable, so I took them off as often as possible. After graduating from the University of Madras, I went to Australia as an intern and later joined the University of New South Wales as a graduate student. I saw my first computer in 1959, a vacuum tube computer by English Electric based on the design by Alan Turing. It occupied a very large room and it was awe-inspiring. I learned how to program by watching my advisor, Stan Hall. After working for IBM for 3 years, I joined Stanford in 1963 as a graduate student in AI, working with John McCarthy. DARPA just started funding AI research at CMU, MIT, and Stanford, we soon got a brand new PDP-1. After everyone went home at the end of the day, I was the only one left using the PDP-1 all night, every night. Having come from IBM, where an hour of computing time cost $1,000, it was heaven. From Stanford, I moved to CMU in 1969. The computer science department was small and had less than 10 faculty. Out of those humble beginnings at CMU came cars that drive themselves, smartphones that see, hear, speak, and answer questions, systems that understand and translate languages, and cloud computing that provides anytime, anywhere access to information and computation. Today, that department has grown into a school of computer science with 7 departments, 240 faculty, and 2,000 students. Built on a foundation laid by Alan Perlis, Alan Newell, and Herb Simon, we were able to create an innovative and empowering environment that continues to today. Unfortunately, half the world does not yet benefit from the technologies we are helping to create. For example, it is my hope that the spoken language technology pioneered at CMU can empower people who cannot read or write. They will be able to use spoken dialogue systems in their native language to access services such as banking, e-commerce, and telehealth, even if they cannot read, as well as email, messaging, and social media. By the way, the people at the bottom of the pyramid represent a market potential of $10 billion a day. Looking farther into the future, I see the emergence of personalized guardian angel apps that will get the right information to the right people at the right time, in the right language, with the right level of detail, the so-called AI Bill of Rights. To look at a specific instance, you may remember the Indian Ocean earthquake of 2004 that led to a massive tsunami, killing over 300,000 people. With personalized guardian angel technology, we could have warned people in the impacted zone on the South Indian coast that there is an imminent danger from 100-foot waves in 15 minutes, speaking to them in Tamil language, using words that are understandable by illiterate fishermen. To realize this vision, we will need to create an all-knowing and all-seeing guardian angel platforms. But first, we must resolve the elephant in the room, namely the ethical issues around trying to create the big brother technology, no matter how beneficial it may be. In conclusion, I have been lucky to be with the right people in the right places at the right times. And that has made all the difference. Thank you, CHM, for making me part of computer history.
Congratulations, Raj. It's truly an honor to celebrate you as the newest CHM Fellow. Now, as we continue from the past to the present, let's turn to musical performers who reflect the type of cross-cultural fusion that has been a signature of Raj's life. Like Raj, who began his life journey in India, then traveled to Australia and centers of technology in the United States, tonight's performance combines classical Indian motifs with modern electronic sounds and beats. Taking our stage from Dubai, please welcome Nikki Mookie and tabla virtuoso Arindam Chakravarti.
Thank you, Nikki and Arundam. It's amazing to hear those sounds coming from an electric guitar. It's absolutely stunning. To fully appreciate the pioneering work of Raj and other innovators, we want to showcase some of the impact stories, the ripple effects that have affected so many people over time and around the world. We'll start in Pittsburgh, Pennsylvania. It has been said that great institutions are the lengthening shadow of great individuals. Well, Raj has contributed to building not one, but several institutions, all of which have become world-class centers of excellence in research, innovation, and education. Here to deepen our understanding of Raj's impact on leading world-class institutions is a computer scientist, cybersecurity expert, co-founder of Arbor Networks, and former leader at the National Science Foundation. He is currently the president of Carnegie Mellon University. Join me in welcoming Farnham Jahanian.
Good evening. I'm delighted to have this opportunity to pay tribute to the incomparable Raj Reddy as he's recognized by the Computer History Museum for his lifetime of achievements. As we all recognize, unprecedented technological advances are transforming our economy, our society, and our culture. Raj has had a front row seat and has often led the orchestra as our technology-enabled future has unfolded. He has catalyzed significant advances in robotics and artificial intelligence. And decades ago, his work in speech recognition planted seeds of understanding that have turned into forests of innovation and technology. In fact, modern speech recognition systems, including the ones on our phones we all use today, can proudly claim Raj's earlier work as their inspiration. This evening, you're hearing from other speakers about the ways Raj's work has empowered humanity. So I wish to take this opportunity to highlight Raj's immeasurable impact on Carnegie Mellon. Working with legendary pioneers like Newell, Perlis, and Simon, Raj was instrumental in creating CMU's Department of Computer Science more than 50 years ago. Of course, their technical contributions were profound, but at CMU, it was much more than that. They created a culture of inventing bold new areas of exploration and then making them happen. Over the last 5+ decades, Raj has been the embodiment of this culture. In that spirit, Raj served as the founding director of our Robotics Institute from 1979 to 1991, establishing the viability and opportunities for robotics as an academic discipline worthy of serious study by top scholars and scientists. Of course, we all know how that turned out. He also has helped to launch CMU's Institute for Software Research, which trains top talent in software systems, systems engineering, and social computing. And Raj played an important role in establishing CMU's School of Computer Science as the first college in the world devoted solely to computer science research and education. His leadership, including as Dean of the School of Computer Science during the critical period from 1991 to 1999, has continued to this day to empower and shape the academy. We also see Raj's influence in the innovations that have emerged from the robotics ecosystem, including robots that can traverse the landscape of Mars or work as a surgical assistant, not to mention autonomous vehicles that had some of their beginnings in the Robotics Institute that Raj founded. I should add that this fearless innovation ecosystem has also transformed the Pittsburgh region into a hub for technology. My own personal view as a computer scientist, including my time at other universities and at the National Science Foundation, is that because Raj was one of the early influencers, the bold culture that Raj championed at CMU has pervaded computer science in the United States and internationally. This has driven in many ways the state of technology in the present day. As you all know, Raj has amassed quite a long list of honors for his work: the Turing Award, the Acm Prize, and the Vannevar Bush Award, just to name a few. But his most lasting contribution may be in the generation of colleagues, students, and scholars who continue to learn from and be inspired by him. I know that many of us participating this evening count ourselves in that fortunate group. On behalf of the entire CMU community, I wish to extend my sincere congratulations and deep gratitude to Raj Reddy for his incredible legacy of achievements and immeasurable contributions to our discipline and to our world. Congratulations, Raj.
Thank you, Farnham. It's amazing to see how empowering an institution at the forefront of computing and change can have such a profound multiplying effect through generations of faculty and students. Next, we go to Mumbai to learn about Raj's impact on education in India. Our next speaker is the chair of the board at Tata Sons, the holding company of more than 100 Tata Group companies with more than 750,000 employees. He's a leading voice on bridging the digital divide. We are honored to welcome Natarajan Chandrasekaran.
I am so pleased that Professor Raj Reddy has been selected to be the Fellow of the Computer History Museum. Raj's profound contributions to technology, society, and the underserved communities make him an ideal choice to be the honoree for the 2021 fellow. Those who are using the modern speech technologies have to thank Raj for. Raj has done pioneering work in the field of speech technologies, but he has also contributed in several areas of AI, including task-oriented systems and autonomous robotics. There are many aspects of Raj we can talk about. I am taken by his humility and his focus on the bottom of the pyramid to bring access to the people who don't have it. In India, he has made a huge impact in the areas of literacy and college education. He was instrumental in the setting up of the Rajiv Gandhi University of Knowledge Technologies. Through this, he has given access to thousands of rural children and students for college education. I have had the opportunity to work with him closely in the Indian Institute of Information Technology in Hyderabad, where his contribution to the Indian education system and the startup ecosystem can be very visibly seen. Raj's work in research, technology, and solving the societal problems is something that has to be understood by the future generation. And in fact, his contribution to solve these basic problems using technology is something we should all celebrate. It has been a pleasure to talk about Raj today and share a few thoughts, and it is a special privilege, and I cherish my relationship with him.
Thank you, Chandra. I know we all appreciate your tribute to Raj and your call to empower humanity through access to information, education, and opportunity. The last leg of this journey brings us back to the United States, to Seattle. Our next speaker will share examples of today's cutting-edge applications in speech recognition, translation, and conversation. One of Raj's protégés and colleagues, he founded the Microsoft Speech Technology Group and now serves as Technical Fellow and Azure AI Chief Technology Officer. Welcome, my friend, XD Huang.
Congratulations, Raj. In this very special moment, I would like to share a few stories to celebrate what you have done to all of us and your amazing impact to the society. We are working with the European Union Parliament to help to bring the citizen closer. There are 24 languages spoken in the European Union. We are lively transcribing and translating all languages spoken by the Parliament member, regardless what languages they are speaking. Let's take a look at this video.
Frau Präsidentin, liebe Kollegen, liebe Kolleginnen, ich möchte meinen ganz herzlichen Dank an die Berichterstatterin Katrin Seiler aussprechen, die in diesem hochtechnischen Bereich eine sehr wichtige Arbeit gemacht hat. Denn es ist nicht nur ein technischer Bericht, es ist auch ein hochpolitischer Bericht, den wir vor uns liegen haben, in dem hohe politische Standards auch respektiert werden mussten. Es ging darum, die Belange der Wirtschaft, der Sicherheit, des Arbeitsschutzes miteinander in Einklang zu bringen. Und es ist ihr aus Sicht des Europäischen Parlaments und der Sozialdemokraten und Sozialdemokratinnen hervorragend gelungen.
Thank you, President. Well, some colleagues took the initiative of putting in the agenda an urgency resolution on Brazil's refusal to extradite Cesare Battisti to Italy. I do understand their motives, but as I shall demonstrate, this is not a present human rights case, it is not an urgent case, and it is not even a breach of the rule of law case.
As you can see, this amazing speech translation capability is helping people to communicate better. This can be traced back to what Microsoft licensed, the speech technology from Carnegie Mellon, when we first established the speech program in 1993. That helped set the foundation for Microsoft Speech Program. Thank you, Raj. Another story I want to share is Seeing AI. This is the app you can download from the App Store for your mobile phone. Let's take a look at this video.
I'm Saqib Sheikh. I lost my sight when I was 7, and shortly after that I went to a school for the blind, and that's where I was introduced to talking computers, and that really opened up a whole new world of opportunities. I joined Microsoft 10 years ago as a software engineer. I love making things which improve people's lives, and one of the things I've always dreamt of since I was at university was this idea of something that could tell you at any moment what's going on around you.
I think it's a man jumping in the air doing a trick on a skateboard.
I teamed up with like-minded engineers to make an app which lets you know who and what is around you. It's based on top of the Microsoft Intelligence APIs, which makes it so much easier to make this kind of thing. The app runs on smartphones, but also on the Pivot Head smart glasses. When you're talking to a bigger group, sometimes you can talk and there's no response, and you think, is everyone listening really well, or are they half asleep? And you never know.
I see two faces, 40-year-old man with a beard looking surprised, 20-year-old woman looking happy.
The app can describe the general age and gender of the people around me and what their emotions are, which is incredible. One of the things that's most useful about the app is the ability to read out text.
Hello, good afternoon. Here's your menu.
Great, thank you. I can use the app on my phone to take a picture of the menu, and it's going to guide me on how to take that correct photo.
Move camera to the bottom right and away from the document.
And then it'll recognize the text. Read me the headings.
I see appetizers, salads, paninis, pizzas, pastas.
Years ago, this was science fiction. I never thought it would be something that you could actually do, but artificial intelligence is improving at an ever faster rate, and I'm really excited to see where we can take this. As engineers, we're always standing on the shoulders of giants, building on top of what went before. And in this case, we've taken years of research from Microsoft Research to pull this off.
I think it's a young girl throwing an orange frisbee in the park.
For me, it's about taking that far-off dream and building it one step at a time. I think this is just the beginning.
As you can see, we can help people with vision impairment to understand their physical world. AI for Good was inspired by Raj and his work at the CMU. This is a combination of using computer vision and computer speech to help people be more productive. AI for Accessibility is an unfinished journey. There are 7,000 languages spoken on this planet today. To help everyone to communicate better, we have to finish the unfinished journey. Raj Reddy inspired, supported, and advised numerous people working on AI. For example, 3 out of 4 managing directors in Microsoft Research Asia were all Raj Reddy students. We appreciate deeply what Roger has done to empower, inspire, and supporting all of us. But most importantly, it is the vision and the friendship that means tremendously to all of us. Thank you, Raj. Congratulations.
Thanks, XD. It's really exciting to see how these technologies are making a difference in people's lives, creating more inclusion and access and helping break down barriers that divide us. Provides hope for a brighter future. And speaking of the future, I want to let you in on a story about Raj and some of his colleagues and friends. During the 1990s, Raj and other distinguished computer scientists served together on the Microsoft Technical Advisory Board. It's also known as the TAB. After gathering from around the world for meetings in Seattle, they often spent the evening chatting over dinner. Raj, a perennial optimist, as you've seen, about the potential of new technologies on the horizon, would often make a prediction about the future. Something concrete, but always audacious. Not surprisingly, that would lead to a friendly wager among a group about whether that prediction would come true or not. They made these bets on the future for nearly a decade. Well, what were some of the bets? Let me give you a few examples. In 1993, they bet that within 10 years, AI would have more impact on society than the transistor. In 1996, they bet that by 2006, a production car would be available that drives itself and costs less than 20% premium over other cars. Their bets usually focused on computing, but once they even bet if Arnold Schwarzenegger might run for governor and win. Really. What were the stakes? They ranged from dinner of the winner's choice to $1,000. And they did keep track of who won and who lost and who paid their bets. So tonight, we're going to have a little fun and play a game called Bet on the Future. And as a surprise, we're excited that 5 of the original group have joined us tonight live for a reunion. First, let me introduce Ed Lazowska. Ed is a professor and chair emeritus of the Paul Allen School of Computer Science and Engineering at the University of Washington. He focuses on computing and communication systems, data-intensive discovery, and public policy issues. Welcome, Ed. Next, meet Gordon Bell. Gordon served as a computer science professor at Carnegie Mellon. He led research and development at Digital Equipment Corporation and was a researcher at Microsoft. Here at CHM, we salute him as the co-founder of our original museum, and in 2003 as a CHM Fellow, and a long time, even today, active trustee. It's always great to have you with us, Gordon. In the center is Raj Reddy. Well, we've been celebrating him all night, so he's not going to get any further introduction. Next is John Hennessy. John is a computer science professor and the director of the Knight Hennessy Scholars at Stanford University, where he also served as the 10th president. He co-founded MIPS Computer Systems and Atheros Communication, and now serves as chair of the tech firm Alphabet. John, we always appreciate you joining us here at the museum. Last, but by no means least, please welcome Andy Van Dam. Andy is a professor of computer science at Brown University, and we look forward to honoring Andy as another 2021 Fellow Award recipient on September 23rd for his lifetime of contributions to computer graphics, hypertext, and education. Welcome, Andy. And of course, to serve as our host for the game show, please welcome back Dr. Talithia Williams.
Thank you, Dano, and welcome to the world's favorite game show, Bet on the Future. Hello, gentlemen. It's such an honor to be with you tonight. We look forward to hearing your vision of the future. But before we get started, there's one more important player in our game, and that is you. That's right. Once we hear from our honorary panelists, we want to see how you bet. If you look above the chat, you'll see a tab that says Bet Here. Just hit that, and you can place your bet, yes or no. You can vote whenever you make up your mind. And now to get things rolling, I'm going to throw it to tonight's honoree, Raj Reddy, to give us his 2021 prediction for the future.
Raj, you have to unmute.
Yeah, I just unmuted. So thank you for the opportunity to give yet another bet. I want to thank my friend Andy Van Dam for introducing me to Douglas Adams and Babelfish in the Hitchhiker's Guide to Galaxy. Babelfish acted as the universal translator. So my prediction today is we will have a digital babblefish, which will hide in your ear and translate all the languages of the earth. To be more specific, in 10 years, anyone will be able to watch any movie or talk to anyone in any language. Why do I think I might win? Speech-to-speech translation technology has already been demonstrated for languages important for business. We just need to collect enough speech and language data, about 100,000 hours of speech and 100 million words of text for 100 or more orphan languages to realize the goal. This is doable. Why I might lose? It turns out the technology is not enough. You need accessibility and ease of use. The current UIs of Google Translate and Microsoft Translator, both of which are available as apps on your iPhone, are clunky. It's kind of painful to use them, but they work. But getting 100 or more orphan languages is going to take a lot of time. For the same reason, Apple Watch will never become a runaway bestseller like iPhone. Conventional tools that we now have for translating languages are not going to work. It has to be completely non-intrusive. That's why I like the metaphor of babblefish. It must be in your ear, hide and nobody, and then translate everything that's being said in all languages, recognize the language and translate it. And I'm saying all languages, we can settle for maybe the 100 most commonly used languages, because the rest of them can be derived from them. And it turns out all of them, each one of them are spoken by 10 million people or more. So that's my prediction, that we will be, in 10 years, anyone will be able to watch any movie. And that's very important, because most people don't necessarily want to talk to someone else speaking another language, but they want to be entertained. And the number of movies available in all the languages is significantly larger than any of the orphan languages. Or talk to anyone in any language. That's it. Thank you.
Well, I love that, Raj. I mean, I can't wait to put one in my ear so I can eavesdrop and see if folks are talking about me in another language. But just to see how much we're betting, let's hear from Gordon Bell. Take it away, Gordon.
Okay, well, I'll bet against that. In this case, against my better judgment. But on the other hand, I have a very good success ratio of betting against Raj. This does have a fundamental problem, is that I don't expect to be here in 10 years, according to my parent, based on my parents and how I'm feeling and all of that. But I will let my granddaughter, who's a computer scientist or a budding computer scientist, take me over. Now, on the other hand, how much is it? This is usually a $1,000 bet. So now the old $1,000 is really a $2,000 bet. Now, today, I looked at the CPI, and by the time we pay off, it'll be back to worth $1,000 again. So I'll make it a $2,000 bet. The Computer History Museum will hold the stakes and be the judge as to who wins and loses. If we've got some very wild side bets, then I think it may end up as we just put money in the pot, and the winners at least get their money back on that, because I have a fear that people are going to totally agree with Raj, which is not good for me as a bettor here. So anyway, this is a good one to bet on, and I hope it's all going to happen. But I'm certainly think there are enough things going on in that bet that I can probably figure a way to weasel out of it, no matter how close he comes to it. So I'm on the no. Yeah, I'm in for $2,000. The museum needs the money now, by the way. So I'll turn it over to somebody
Well, Gordon
else.
has bet no against you, Raj. So it looks like we've got some disagreement. He's put up $2,000 in his bet of no. He's not sure if he's going to be around. We're going to have to keep him on ice so we make sure that he's here in 10 years. But let's see if others agree. John Hennessy, I'm coming to you.
Well, for once, I think Raj could actually be right for the first time. I think there are two issues that I worry about in getting to yes on this, Raj. One is the last 10% problem. You'll get most of the way, but those last few languages will. But your choice of the 100 most frequent languages makes it a lot better probability. The other thing I worry about is if we don't find a way to continue Moore's law, you won't be able to stick it in your ear because it'll burn your head up. And so we've got to figure out how to extend that. And that's been so, you look at the progress in AI and deep learning, the progress we've made with hardware to empower those computers has been critical. I mean, that was, you and I talked about this earlier. That's one of the things we were wrong about. We didn't understand how much computer power it would take to really power AI systems at the level of human intelligence. And so those are the things we've got to solve. I'll certainly put up my $2,000 and I'm betting with Raj this time.
All right, so we've got one in favor. We've got one that's not in favor. So, okay, Roger, you're 50-50 now. Let's see who's next. Ed Lazowska, I'm coming to you. Tell me your assessment of the prediction and what's your bet?
I'm going to ask for a clarification. Raj, does the device have to be self-contained or can it talk to your phone as long as it's real time?
It can talk to your phone.
It talks to the cloud. It talks to the cloud, Ed. Come on.
It can be anywhere. I don't care. But the phone must be non-intrusive. It can be in your pocket.
Yeah.
Maybe hidden. But as far as I'm concerned, I don't even want to think about it. If I'm talking to you in Hindi and you're listening to it in English, you should be hearing it in real time and vice versa.
Yeah, to John's point, though, it doesn't have to burn up your ear. It can burn up your pocket. I worry about latency to the cloud.
Right.
Yeah. So as Gordon and John has said, you almost never lose money by betting against Raj because he is such an inveterate techno-optimist. And that's the wonderful thing about Raj. He has, 3 more zeros than anybody else in any, he's just always looking so far in the future. And I think the only time I bet with Raj, I lost, and that was betting that there was no way that we would have the governor of California who we had for a period of time. So I'm going to vote with Raj. The one thing I want to say is I really like the dinner bets, although I will put up my $2,000. I like the dinner bets because the detail was the dinner was of the winner's choice. The losers had to pay, and the price of the wine couldn't exceed the price of the food. And that set a plausible upper bound on what dinner could cost, but it was often way more than $1,000. Okay, so I am with Raj in this case, and I'll put in my $2,000 for the museum.
Thanks, Ed. All right, so we've got 2 bets that are with Raj. We've got 1 that is against. Now, audience, if you haven't done so, I want you to make sure you get your vote in now because we want to see where you land on this. And now let's go to our final panelist. Take it away, Andy Van Dam. What do you have to say?
Well, so there's a spectrum of cockeyed techno-optimism, which our dear friend Raj occupies almost uniquely. And then there are the techno-skeptics, cynics, call them what you like, pessimists. I try to be kind of a pragmatist, and I'm very much in agreement with the last 10% or the last mile problem. I think the pragmatics of the situation really intrude. Where are the financial incentives to nail all 100 languages and to nail them with a lot of background noise and environmental considerations and so on. Having it be robust with that kind of UI that Raj has always preached is a heroic design task that hasn't been solved for any device as far as I'm concerned, not even the iPhone, let alone the iWatch. So I think the pragmatics will intrude and will get arbitrarily close, but not quite there.
That's what makes it, you know.
So Andy, does that mean you're voting against Raj?
I am
or...
reluctantly betting against because I love the quest.
Gordon is so relieved.
I think Raj, Ed, and I are going to have to take up a collection to push the last 10% over the line.
Exactly. By the way, this group has not yet congratulated Raj this evening. Raj, just enormous congratulations and thanks for your friendship over so many years.
Thank you.
Raj, you're our hero.
Indeed.
And our model.
We are mutual admiration society here, right?
Well, we're split 50-50, Raj. We've got two folks that are in support of you and two that are against, but you know who's going to be the tiebreaker tonight? It's going to be our audience. Let's see how our audience voted. Why don't we bring up those results? It looks like 68% of the audience is in favor of Raj's bet. 32% are against it. So thank you so much, audience. You've got some more support there, Raj. I think it's only fair that we give you the last word. Tell us what you think.
I think Gordon and Andy might win this bet, but that's okay because the fun will come in 12 years, so 15 years. I remember when I was with John Hennessy and others in 2007 for the at the Computer History Museum for the Touring Award dinner, and I had just lost the bet about autonomous driving cars and John said, I didn't think it will happen that fast, you know, because in 2007, DARPA Challenge and Grand Challenge was won by Stanford, Sebastian Stern, the car driving 130 kilometers with nobody there. But that's far cry from being able to buy one in the market. And that's the issue is going to be. Namely, it's not enough to simply demonstrate the technology. It has to be usable and friendly and so on. But I'm happy to, I'm sure I have a couple of other friends. We're happy to take Ed and Gordon and Andy to dinner anywhere you want to take us, Gordon. But you have to be around. You cannot leave us. Okay.
I hope the audience is all sending in their bets.
It's been fun to watch you all interact and get to sort of sit at your feet and listen to you have this conversation. And audience, it's been great to get your input as well. Hopefully you're also going to make your donation. It might not be for $2,000, but we'd love to see your donation as well. Thank you so much for playing Bet on the Future, and it's back to you, Daniel.
Thanks to Lithia, and thanks to all of our players. It's just fantastic to peek into the future through the eyes of these thought leaders, and I can't wait to get back together and see who wins the bet. As we look to the future of AI and other technologies, we may not be able to predict what will come next, but one thing we can bet on for sure is that a diverse and inclusive community will be essential to a better future. That will be the only way we can reflect on the promise and perils of AI, robotics, and other technologies, and harness the power of technology to benefit everyone. Thank you all for your participation tonight, and thank you for adding your voices through the chat, social media, and your video messages. Every voice is important. And obviously, special thanks again to Raj. Thank you for who you are, all you've done to impact our lives, and as we've heard tonight, the literally millions of people around the globe. We're inspired by your example of empowering innovators, empowering change-making institutions, and empowering humanity through technology to enable access, equity, and inclusion. And to each of our speakers and supporters, and all of you who have participated in tonight's program, thank you for being part of the CHM community. Together, as technology creators, users, and digital citizens, we can make a difference. In fact, we must make a difference. Ultimately, the future we want to build will depend upon all of us. As we conclude, I invite you to consider, who can you help empower? How will your actions impact the world and benefit humanity? These are the questions we're asking ourselves every day at CHM as we decode technology to shape a better future together.